So Sascha, in the age of agentic AI, what is the role of knowledge graphs and ontologies and semantic modeling?
Talk about agentic AI, the critical piece often missing is context. A system can only make good decisions if it understands how data points and concepts connect throughout the enterprise. That's exactly where knowledge graphs, ontologies, and semantic modeling come into play. If you look at knowledge graphs in more detail, then you can think of them as a network of linked information. Instead of having data in separate databases or spreadsheets, a knowledge graph ties all your key entities, for example, machines, processes, products together, and shows how they relate. For instance, in a manufacturing setup, you're not just storing a machine ID, you're also capturing which process step it belongs to, the materials it handles, and its maintenance schedule. This big picture view is much more powerful than isolated data. And ontologies actually then provide the rules and definitions behind those connections. They act as a kind of dictionary or guidebook explaining how different elements in the graph should be interpreted. In a pharmaceutical context, for example, patient has a specific implications about safety, trial phases, and dosage. So if an AI system detects an irregular reading from a sensor, the ontology makes it clear how serious that is in terms of, for example, regulatory limits or potential health risks, rather than just flagging it as an error. And actually, this context is crucial for an agentic AI. Picture an autonomous AI agent receiving a notification like sensor 101 is running hot. Without context, it can't judge how critical that is. With a knowledge graph and a well-defined ontology, the agent knows that sensor 101 belongs to a key subsystem where a breakdown could affect production or safety. Having that situational awareness helps the agent make the right call, perhaps slowing the process or altering a technician, alerting a technician for urgent maintenance. Another key factor is transparency. So traditional AI can feel like a black box, which is risky if you're in a regulated industry like finance or life sciences. With semantic modeling, you can trace how decisions are made because the AI is referencing clear definitions and rules in the ontology. That's essential for audits, compliance, and gaining trust from stakeholders. And also, as Ashutosh mentioned that already, many agentic applications involve multiple specialized AI agents, one for predicting supply issues, another for scheduling, another again for monitoring equipment. If they don't share a common language, they might make conflicting decisions. And a centralized semantic layer solves that by acting as a universal translator. All agents draw from the same knowledge graph, so they interpret data consistently. This is critical for real-time cross-functional coordination.
Yeah.
And finally,
we definitely don't want the agents to stumble over each other, do we? Right?
No, we don't. Maybe there's one last important part, and that's scalability and flexibility. As your business evolves, introducing new product lines, compliance rules, or data sources, you don't have to rebuild everything. You simply update the ontology to reflect the new definitions, and the knowledge graphics tend to incorporate fresh data. The AI agents automatically gain a more complete and updated view of your operations without needing to be reprogrammed from scratch. And I think that's, in a nutshell, knowledge graphs, ontologies, and semantic modeling provide the foundations that fuel agentic AI, and they turn all these scattered data resources into a well-structured, meaningful resource, helping AI systems make more accurate decisions with greater clarity. And that's the reason why we heavily invested in these semantic technologies for TCG mcube 5.2, because it's how we go from standard automation to truly intelligent, adaptive workflows that drive real business value.
Thank you for outlining the impact of semantic technologies and ontologies on how agents actually can behave and how agents can actually act on our behalf. Let's look a little bit more under the covers, though. So what is the significance of semantic technologies and related ontologies for the foundation of a strong agentic AI strategy, which is the data lakehouse?
All right. Yeah, a data lakehouse combines the huge storage and flexible ingestion of a data lake with the structured query capabilities of a data warehouse. This means that you can keep a lot of raw data in one place while still querying it efficiently. Now, that's useful if you just want to store and retrieve data. But as soon as we talk about agentic AI, we need to go beyond just storing things. We need a layer that helps AI interpret, govern, and apply this data in a context-aware way. That's exactly where our new module Semantics within TCG mcube comes into play. Its ontology-driven approach serves as a single repository for semantic models, ontologies, control terminology, and metadata, making it easier for both systems and users to find and use relevant data. You can think of a data lakehouse as a library with massive amount of information. By itself, it doesn't really tell you what each book contains or how they relate to each other. Semantic models serve as the catalog system, describing what each data set means, how it should be used, and how it links to other data sets. An ontology is basically the blueprint that defines the concepts in your domain, like machine, maintenance schedule, or production goal, and the rules that connect them. And this is critical for agentic AI. An AI agent might be pulling data from sensors, enterprise apps, or external sources, and then deciding how to respond. Without a semantic layer, the AI just sees raw data. It can't tell whether sensor 101 is part of a key subsystem or just a secondary device. With ontologies, the AI knows exactly how these elements fit together and can make well-informed decisions. It can alert a human operator if something critical is failing, or even take preventative action by adjusting processes automatically. And you also get traceability in regulated industries, healthcare, finance, pharma. You want a clear record of which data was used and for what purpose. Semantic metadata can capture lineage and usage rules so that you know exactly who or what accessed certain data and why. And this is invaluable for compliance and building trust in autonomous decisions. You can say, yes, this AI recommended adjusting production because it analyzed these 3 data sources under these conditions, and it's all documented right there in the ontology. And we've talked about cross-functional collaboration already. Ashutosh made that point quite clear. In a plain data lake, each department might dump their data with different labels, creating a data swarm. Semantic models bring a common framework so everyone labels and references data consistently, and this makes it easier for new AI agents and actually for analytics teams as well to discover relevant information without having to translate a bunch of ambiguous field names. Essentially, it saves time and reduces confusion because all the data is described in the same shared language. And embedding ontology in your data lakehouse lays the foundation for adaptive and explainable agentic AI. These AI systems don't just retrieve data, they learn from the relationships defined in the ontology and can adapt when those definitions change. So this means you can add new products or new compliance rules, and you can simply update the ontology and your AI agents automatically operate with this new knowledge. And I think this is a future-proof approach because you're not hard coding every rule into the AI. You're letting the semantic layer handle that. And the AI can also show you the reasoning path it took, which is huge for trust and transparency, especially if you need to demonstrate how a particular decision was made. So yeah, summarizing all that, semantic modeling, knowledge graphs, and ontologies are what transform the data lakehouse from a massive storage space into a knowledge-driven platform for agentic AI. This extra layer of meaning and context makes a big difference and how effectively and responsibly your AI can handle real-world data and automate complex decisions.